Okay, good morning everybody, or good afternoon maybe for you guys. I'm sick today, home unfortunately, so you can learn the next two or the first lesson via video. And just watch it, and then you're going to do some practice problems. So you're going to pause, do some practice problems, check them, watch another video, or continue watching, then do practice problems, and then you'll do your homework. So during class on Monday, I will check your notes, so these pages for your notes, and I will also check the worksheets for your homework. So you have two different sets of stapled worksheets you should walk away with, and both sets are due on Monday during class. Okay, so you've already done dividing monomials a little bit. Oops. So you shouldn't have too much difficulty, I hope. So let's see. So if we had x to the fifth divided by x cubed, we would get x to the second power. If we had x squared divided by x to the sixth, we would actually get 1 over x to the fourth. Okay, why is that? Well, let's look at the rule. The rule says when dividing monomials with like terms, or like, not terms, sorry, but with like bases. So here, x, these have to match, so x and x. So x and x, those are the same. So like bases. Then we would subtract, so we're going to subtract the exponents and put the result where the larger or bigger, where the larger exponent is. So here, if there's 6 x's in the denominator and 2 on top, x times x, and then x times x times x times x times x times x, well, if we cancel, that's 1 for 1. We still have 4. Where are they? They're in the denominator. Well, what happens when you cancel these? X divided by x, those are becoming 1s. X divided by x, those are becoming 1s. And 1 times 1 is just 1. Here, there were x, right, so that's x to the 5 minus 3 power. Well, it's in the numerator. How many are left? It's 5 minus 3, which is x to the second power. So now we're going to throw in numbers and variables. So you do them separately. So first thing you want to focus on is your numbers. Remember, you can use math frac. What is 15 divided by 5? Well, they're both divisible by 5, so 5 goes into itself 1 time, and 15 divided by 5 is 3. So I'm going to have 3 in my numerator and 1 in my denominator. And then if both of these are n to the 1 divided by n to the 1, well, what happens to those n's? They're the exact same amount. So they just cancel each other out and become 1s. So we get 3 times no n, so the answer is just 3 there. Here, let's do our numbers separate. So 9 divided by 12. Well, they're both divisible by 3, or you can use your math frac button. 9 divided by 12, math frac, enter. It will reduce it for you. They're both divisible by 3, so we would get 3/4. So I have 3 in my numerator, 4 in my denominator. Now let's do our variables. We have y to the 4th divided by y to the 1. Well, 4 is bigger, so your leftover variables are going to go in the numerator. 4 minus 1 is 3, so we get 3y to the 3rd power divided by 4. Okay, same thing. Numbers first. -7 divided by 28. Math frac. Divide each by 7. We're going to get -1/4. So 1 in my numerator, -1 divided by 4. Then we do our variables separately. Well, we have our a's. These are like bases. That's a squared divided by a. Well, 2, remember this is an invisible 1. 2 minus 1, it's bigger in the numerator, so my leftovers are going to be in the numerator. So 2 minus 1 is a to the 1 power. We don't need to write the a to the 1 power. Then you have your like bases of b's. We have b cubed divided by b to the 1 power. Well, 3 minus 1 is 2, so we have b squared left over in the numerator. I should have done that in a different color. So b's. And then finally, we have our c's. Well, there's only one c. It's in the numerator, or sorry, in the denominator. There's nothing we can cancel then if it's just by itself, so it just stays in the denominator. So our final answer is -ab squared divided by 4c. So this here is our final answer. Number 4, let's do our numbers first. Negative 12 divided by negative 20, math frac. They're both divisible, they're both negative. Negative divided by negative, it turns into a positive. You divide both of them by 4, you should get positive 3/5. So 3 in my numerator, 5 in my denominator. Look at your r's. R squared divided by r, that just gives us r to the 1 in the numerator. Look at our s's, we have s divided by s squared. There's more s's in the denominator. We go 2 minus 1, but the leftover s to the 1 power is in the denominator. So this is my final answer. 3r divided by 5s. Okay, moving on. Now we're getting to a little more complicated ones. We need to apply the rules we just learned. So the rules we just learned was taking 3s to the 4th power. So we're going to distribute the exponent of 4. Oh, sorry about that. Let me try that again. We're going to distribute 3, so it's 3 to the 4th power times s to the 4th power divided by, our denominator stays the same, so that's just 3s to the 4th power. So if we look at our numbers separately, we have 3 to the 4th divided by 3 to the 1. Well, 3 to the 4th divided by 3 to the 1, we do 4 minus 1, so that's 3 to the 3rd power, that's in my numerator. And then what happens to my s to the 4th and s to the 4th? They're identical, so they cancel each other out, so there's no more s's, so we just have 3 to the 3rd power, which is 3 times 3 times 3, 27. Okay, 6. We have a negative to the 4th power. What is negative to an even power? It becomes positive. And then we distribute a to the 4th, b to the 4th. So it's positive a to the 4th, b to the 4th, divided by negative a cubed. What do? We group these. So these have common bases. So a positive divided by a negative is going to make this answer overall negative. And then what do we do with the exponents? We subtract. 4 minus 3 is 1, so that's a to the 1 power. And then we have our lone b out there on its own. Right, so this b is just sitting out here on its own, doesn't have anything to cancel with, so it just stays as part of the answer. So it's negative a times b to the 4th. Now can we do the same thing with numbers? Sure. These are the same base, 10 and 10, they're both the same base, so we're going to apply the same rules. We just subtract their exponents, so 7 minus 5 is equal to 2. Well, it's 10 to the 2nd power, right? So it's 10 to the 2nd power, but where does it go? Does it go in the numerator, or does it go in the denominator? Well, 7 is bigger than 5, so we have to put the 10 squared, or 10 to the 2nd power, in the denominator, so it's 1 over 10 squared. And 10 squared is 100, so you have to simplify that, so you get 1 over 100. And finally, this last one here, we have same bases. 10 to the 6 divided by 10 cubed, so that's 10 to the power of 6 minus 3. This time it stays in the numerator, because the 6 is on top and that's bigger, so it's 10 to the 3rd power. And then we have our 12 divided by 4 separate. Those don't have matching bases, so we have this out here on its own. Well, what is 12 divided by 4? That's equal to 3. So we have 3 times 10 to the 3rd power. So that's 3 times 1,000, which is just simply 3,000. Okay, so have a little pause. Do the back of this sheet of paper now, and then check your answers as soon as you finish. Okay, so here you have the answers, so you can check them carefully. You might want to pause the screen and then see if you got all the right answers, or look at them here. So you should have gotten 1 over 100 for 1, 4 for number 2. 3 is x squared over 2, or 1/2 x to the 4th, sorry, x to the 4th divided by 2, or 1/2 x to the 4th. 4 is 3/10. 5 is 2q over 5. 6 is negative 3xy over 4. Okay, so check those. If you didn't get those right, then pause and try to go back and fix them. Okay, so for the last 3, you can continue. So we take the numbers, 42 divided by negative 48, they're both divisible by 6, so we get negative 7/8. So I put that up here, negative 7 divided by 8. I look at my y, there's no other y to cancel, so that stays by itself. There's no other x, so I keep the x, and then I have z to the 4th divided by z cubed. So I have more z's on top. How many more? 1 more, so I have to add a z up there on top. So it's negative 7yz divided by 8x. For number 8, we're going to have to distribute exponentially. So 5 to the 3rd power times a squared to the 3rd power, which is a to the 6th. Here it's 5 to the 2nd power times a cubed to the 2nd power, which is a to the 6th. I look at my 5s, they have the same base, so there's 3 on top, 2 in the denominator, so there's going to be 1 left over in the numerator. My a to the 6's, they're identical in amount, so they cancel each other out, so I just have a 1. I don't need to write the 1, so my answer is just simply 5. And finally, I have to distribute this 7, so I have a negative a to the 7th power. Remember, when you have a negative to an odd power, it stays negative. So it's just simply negative a to the 7th. A negative a to an even power is a positive, and then it just simply goes to a to the 4th. Why is that? Well, that's an invisible 1. And negative 1 to the 7th power, that means negative 1 times negative 1 times negative 1 times negative 1 times negative 1, 1, 2, 3, 4, 5, 6, 7. 2 of them make a positive 1. The positive 1 times negative 1 make a negative 1. The negative 1 times negative 1 make a positive 1. The positive 1 times negative 1 make a negative 1. Negative 1 times negative 1 make a positive 1. A positive 1 times negative 1 make a negative 1. So that's why we have a negative altogether here. So negative divided by positive makes my overall answer negative. I have 7 a's in the numerator, 4 a's in the denominator. That's 3 left over in my numerator, so I just get negative a to the 3rd. I'm sorry, that's all I can do today. If you want to try to move on, you can. Otherwise, you should get the homework assignment of just these problems and practice them. And then if there's still time, you can work on your pi, or, yeah, it's up to you. So I can't move on. We'll do that next class. I just can't talk anymore. Okay, I hope that helps. I hope you understand, and I will see you on Monday. Bye.